All right. So thank you, everybody, for joining us tonight. My name is Maria Emanuel, and I'm the Associate Director of UNHInnovation. I oversee our intellectual asset management group here. And I think we have some first-timers, so I'll give you just a very brief background. What we try to do is once a month have a discussion, and we title this series A Conversation About, and we invite industry members and folks at UNH who do work or research in a related area to come together and talk about different topics and the challenges and successes that they see and ways to integrate our various efforts together. And so we have a great lineup for this fall. This is our second series. Next month, on November 17th, we have Craig Morris joining us, and he is from the U.S. Patent and Trademark Office. He's their managing attorney for trademark educational outreach, and he's going to be presenting about trademark fundamentals in businesses. So any questions you might have about what are trademarks, how do you apply for them, how does the process work, how do you use them as an asset, this will be a great discussion. We had a patent examiner from the USPTO here last year, and it was a really just vigorous conversation and a lot of opportunities to talk about topics that were specific to your interests. And then on December 15th, our conversation is all about networking. So that's our annual networking event. It's Eat, Drink, and Be Merry. There will be no actual content delivered, but we'll have a chance just to socialize. And then we will be announcing our topics coming forward for the spring semester. So following today's presentation, there will be, because we love to do this, there's a networking period. And so we'll have that immediately following. It'll be in the next room. You can continue to find some beverages and some snacks, and then to get to talk to others who have joined us tonight. And I wanted to give a special mention to our sponsors for our seminar series. Our gold sponsor is Finch & Maloney. They're based out of Manchester, and they're an IP firm that really deals with patents and looking at different technology advances. And then we have Saunders & Silverstein as our silver sponsor, and they are out of Amesbury, Massachusetts. And they provide services related to copyrights, trademarks, software, internet, and entertainment law. So importantly, tonight we're here to talk about a conversation about university and industry collaborations. So there's lots of ways that we here at the university hope that companies think about us as their neighbor, whether we're a virtual neighbor or an actual neighbor to them. And it could be anything from talented interns to new hires, professional development for their ongoing workforce, research, licensing cool innovations developed at the university, come see us, great hockey. And on the other side, we have a lot of ways that we at the university, in many similar respects, think about working with companies. Probably not for interns, but for ways to reach their workforce, to be able to place our hires, to look at interesting research opportunities together. And if we take a step back and think about how do we hope that both parties gain the most benefit, we really want to look at what could be some of the key defining moments for the relationship. Why is it worth each party's interest? And so one perspective will be presented tonight about this chance to develop collaborations to the benefits of both parties. And to do that, we have two great speakers who look so excited to be joining us tonight. Phew! Worried about that one. So from EMSL Analytics, we have Jared Kelly, and he is the lab manager out of their Salem office. And Jared is a physicist, microscopist, and scientist, and has over his career, or that's what he tells me at least, there was no test or qualifying exam to say that, over his career has looked at different ways to help meet unsolved problems of companies dealing with analytics and protocols and testings and so forth, and has worked with a variety of different institutions in Massachusetts and New Hampshire. And we have Shawn Banker, who's our director of the University Instrumentation Center. Shawn's been here for two and a half years, following a tenure at Velcro. And Shawn
22.
has a 22-year
22-year tenure at Velcro. a conflict of terms.
Oh, I'm sorry. You said I'm already interrupted.
I know. I'm just going to say that's older than me. So anyways, and John has a mechanical engineering background. He likes to tinker with things. How's that?
There you go.
But since coming to UNH through the UIC, they've been looking at very innovative ways to be able to engage outside collaborators, to be able to develop some new technologies and new solutions that are of interest to them, and to also meet unsolved needs. And so they're going to talk to us today about the initial relationship that they developed and how that's turned into a collaboration. They said that small questions along the way are great. The philosophical ones they'll hold to the end, and if they're hard, shoot them over to Jared. Shawn's out. So with that.
So today we titled our discussion "The Tale of Two Analytical Labs," right? So Jared runs a lab, I run a lab, we're working together. And what we're going to talk about is kind of the competitive collaboration. So here we are as, honestly, to some extent, competitors. And we are collaborating on a number of things. And we're going to give you the story of kind of where we came together, kind of where we progressed, where we are now, where we think we're going to go. We're going to hit some of the successes. We're going to talk about some of the difficulties and talk about some of them that we actually got through.
We'll gloss over some of the other ones.
We'll skip some of those.
Yep. Not all of them. The ones that make us look okay.
So we're also going to take this opportunity to kind of give ourselves a little commercial, if you will. Kind of talk a little bit about what our capabilities are, so some of you folks who are not familiar with us get an understanding of what we're here for. So the University Instrumentation Center, we're basically a group of engineers and scientists that support research on campus, specifically in the instrumentation area, across a variety of disciplines. So we're not necessarily experts in in one specific area. We're kind of diverse. We are a FDA registered lab with an audited quality management system. That doesn't mean we're ISO 9000 certified and so forth, but we do work for companies that require that FDA registration, and those companies do audit us. So we've got some of the systems in place to be able to do that. Don't expect you to read it per se. I just want to show you kind of the general, where does the UIC fit in the university? So up top, we're in this area here, we're one core research facility at the university. There's many, and I've listed several of them up there. That's not all of them. But within our core research facility, instrumentation, we have several individual cores as well. So we have a spectroscopy core, an imaging core, engineering services core, and within there we have a series of instrumentation that you can see here. We also help coordinate access and help facilitate use of instruments across campus. So we may have these 10, 15 instruments located in the UIC. There's also tons of instruments across campus that we interact with and can help provide access to. Who do we support? Anybody who needs support. But basically, outside the university, startups. One of the things that works well for us is a lot of startup companies have the technical knowledge, they have whether the engineers or scientists to develop these new products, but they don't have the capital, the investment in instrumentation to be able to do what they were used to doing, maybe at a big company or where they came from, or when they're at a university. We have those types of equipment that we can help support those. Research and development, manufacturing, and I'll talk a little bit about kind of some of the applications or where we've been able to help. Analytical laboratories, Jared's company is an example. Other universities, and we do some K through 12 just to help promote STEM and science. And then private citizens. We have people come to us off the street that we will, I shouldn't say off the street, you know what I mean, that need assistance, maybe need some guidance, maybe even need some testing for a project they might be working on, entrepreneurs. This is an example. This is kind of going to be a little bit of the focus of today. Our new scanning electron microscope. It was my present when I started here. So they had it sitting on the floor when I arrived, which was nice. But we're going to talk a lot about that, and that's in our new imaging facility. and just kind of give you a look at it. Some of the applications that we focus in, for manufacturing companies, maybe identifying, I got a contaminant, I'm not sure what it is, we can help them with that. Failure analysis, help in those areas. Process control verification, I've got a process, I made a change, what's the effect on the product, things like that, we can certainly help in a variety of disciplines. Chemical analysis, and there are some others listed. And one of the important one is a competitive product evaluation. So somebody may have a competitive product, they want to understand what's going on with that. We can help facilitate that, gaining that information.
So EMSL is it's a company. We're actually international, and we in a lot of ways do much the same sort of thing as the UIC. We are an analytical testing lab, and so we basically will perform testing for anybody who needs it. The difference is a little bit in the scale department. We have a really wide range of services. We do everything from R&D startups through Fortune 500 companies, manufacturing, process engineering, all that sort of stuff, as well as the all one-off special sort of homeowners and that sort of thing. We have 46 locations across the country. We have 5 locations in Canada. We have a satellite location in Europe. We're relatively large, and we're considered one of the biggest and hopefully the best companies in the country. We have 700 employees, and we've been doing this for 35 years. So, we've seen a fair bit across that period of time. My laboratory just got started up in Salem just a little while ago. It actually, we'll go into that. It's right about the same time Shawn was starting. So effectively, we handle all the same clients as the UIC. We do research and development, we do manufacturing process control, we do quality assurance, we do environmental testing quite a bit as well, which can include air, water, soil sampling, all that sort of thing. We do industrial hygiene, chemical safety, monitoring, environmental fallout analysis. So we did a lot of work with 9/11, all that sort of thing. And basically our business model is that we serve in many ways as sort of consultants for people who have problems. So they come to us with a problem, they say, well, this is what I want to try and get out of this. We sort of sort through our bag of tricks and figure out what tests make sense for that particular problem, and we boil it down, perform the testing, analyze the results, and give them some solutions for what they need. So, as I said, because we have 700 employees and 40-something labs, we have a really wide range of different services that we can offer. Some of what our laboratory in Salem, New Hampshire specializes in is a lot of high-tech semiconductors, microelectronics, a lot of defense, composite materials, ceramics, that sort of thing. We do a lot of failure analysis. We do a lot of manufacturing troubleshooting for people. And we can talk about that later if anybody's interested, but it's a pretty large list.
So I'll give a little more background so you know a little bit about us. You can see kind of the overlap. There's a lot of overlap, right? Some things that, when you're getting together and going to collaborate, you're going to do it for a reason. There were some things that happened that are important, worth noting. In 2014, May 2014, there's a company over in Salem called Custom Analytical. They did environmental testing mainly, I think.
Yeah, it was actually more aerospace.
Aerospace,
so they
okay.
had done a lot of aerospace work for Lockheed Martin, that type of thing. And over time, one of the owners, the principal, had decided that they were kind of in the process of wanting to retire. So they were selling the business. And so EMSL stepped in, wanted to start a new materials and research facility.
So they purchased Custom Analytical in May. I actually joined in May, about the same time, towards the end of May, as the director of the UIC. And then they brought Jared in from Microvision, I think it was, right?
Yep, right in June.
In June, and we had our new microscope show up just before I got here. And also, Jared's company also invested in a TestScan SEM. Different capabilities.
Yeah, a little bit more of a simple unit, but definitely a good instrument. But we were both sort of in the same ecosystem at the same time.
UNH, we held our Imaging Core open house where we basically opened it up to about 150 people to come in from industry, from all over the place, to really showcase what we were doing with this new SEM, as well as there are other facilities that we have in the UIC. And at this point, we were both charged with some key focus things that we needed to focus on, which is why we were brought on board. In Jared's case, he was charged with really expanding the laboratory, expanding the capabilities, and really in the technical, higher technical area. Jared comes with a lot of technical experience, and they wanted to apply that. And I came with we want to do more collaboration, we want to do more work, more engagement with industry. So
basically kind of the same thing. We both were looking for people who wanted to do some laboratory testing in the New Hampshire defense, high-tech sort of areas.
So there was some alignment there, so we happened to take advantage of that. Did I miss one?
No, you're good. So no matter what, even if you're not looking to start a sort of cooperative venture with some people, there's always going to be challenges when you're trying to start something up new. In my case, it was a whole new lab that we basically had a blank building we were starting up from. In Shawn's case, he had something of a structure already, but he had sort of a new directive, and so those challenges are different depending on who you are. Yeah, so I mean, effectively, for us, when we're trying to, your boss says go out and get some new business, that's fantastic. But when he says go out and get some new business from an area, an entire market that we haven't actually done any work with before, it's a little risky, and there's a lot of groundwork that has to be laid. And so a lot of the challenges that we face wasn't necessarily with the competency or knowing who to go after, but it was basically all the infrastructure, the upfront costs. The sort of, the time to profitability type stuff that you do in private industry. You have to worry about all that stuff. And so, trying to do that in balance, also doing, the day in, day out work is a little bit tricky. So effectively, again, we were both trying to start up exact same time. We were both strongly interested in going after the same clients in New Hampshire. And we were both installing new SEM-based systems from the same manufacturer at the same time. So.
And we were both new to the companies or the organization we were working for. And along comes Tim.
So we
blame back, by the way.
We blame Tim Piper for all of this. So Tim was the salesperson for the microscope vendor, and so in his inestimable wisdom, he suggested that perhaps we might want to start working together. So from Tim's perspective, he really wanted UNH to be a great demo site for showing off the capabilities of this new instrument. He wanted to make sure that it was successful by driving clients in. He wanted to make sure that our microscope was successful. And then, I'd been working with him on a number of projects for a while, so he was, hoping that would help out. And at the end of the day, it would be great if he could sell more microscopes because everybody loves the product so well.
Which would allow him to wear more of these types of shirts. So Tim basically, and by the way, if you get a chance, ask him why he uses 2 M's in his name. He'd love to tell that story. So when we looked at, you saw some of the benefits of why, or the reasons why we would want to collaborate. And so here I am sitting here with a brand new high-end SEM. I've got this beautiful instrument. And quite honestly, we had a fair amount of open capacity. The faculty were ramping up and learning how to use it. We were learning how to use it. And we had a directive to go ahead and increase the demand. And Jared?
Well, and I had a pretty good knowledge of all the different types of people who would be able to use that kind of instrument, but with the price tag being what it wasn't something that my company was really super excited about jumping right into, because most of them didn't actually understand how most of the machinery worked. So I knew that Shawn had the time and had the instrumentation, and I had clients who needed it. So there was a nice mesh. He needed people to be using the equipment. I needed to be using that equipment, and so that was how sort of we started out. But the point is, that's not always how it actually plays out. Is where we're basically going to find out.
So from a UIC standpoint, initially, we were looking to fill some open capacity. We're looking to provide some revenue, get some supplemental revenue to help us continue to support the university. And we were always looking for one more client. And really what happened, those things did happen, which was great. Some other things that happened that were really not planned initially was staff development for our UIC scientists happened. We get so much training with the instrumentation provider, the manufacturer, and we send people to training. But really, to have somebody be able to help with that training was a very big benefit to us. So that was clearly a huge benefit to us for ramping up our capabilities quicker. We got introduced and continue to get introduced to applications that are not being worked on at the university, that are outside the university that we normally wouldn't get access to, and real life hands-on application exposure. We helped or got assistance in developing workshops, or a particular workshop to showcase the capabilities well in advance when we would normally be prepared to share that with people, because we were able to rely on Jared to help us with that. And then where we're moving on to now, and you'll hear about towards the end, is okay, so we've got more business, we've got more capability, we've got more opportunity to offer to university, faculty, researchers. We also want to be able to have mechanisms to create research opportunities that are beyond the UIC. And we'll talk about that kind of at the end or a little bit later.
So from our perspective, we were really, we were looking to try and tap into some of these really high-tech firms. And it was challenging to try and figure out a way that we could offer those types of FibSem services to them. In partnership with the UIC, we were hoping to, and ultimately did a great job at being able to work through that and offer these sorts of services to clients in a way that they might not be able to get it otherwise. So we were really also hoping to help the UIC kind of solidify their process for working with different industry partners in a lot of ways, and I think that worked out pretty well. On top of that, we were also hoping that, hey, every once in a while there's probably going to be somebody who approaches somebody at the UIC, is interested in doing some testing, but it's not a good fit. And because we have such a wide network of capabilities, we're thinking there's a good chance that we might actually be able to, sort of fill in those needs as needed. And so, yeah, we've definitely seen progress at all of those things. We've really found that work out, but we've also found that in working through this, we've been able to work with them to get an idea of how the market works, what different clients need, costing, that sort of thing. So we've been able to get valuable business intelligence for our own operations. And we've also found a means, as Shawn was alluding to, for new research opportunities. So sometimes we'll get people who want to do a really complex testing scheme. And it's a multi-stage thing, and for a contract analysis lab, it's not necessarily the best fit. And so we've been starting to reach out to the university and say, well, when we have a client like this, we can find partners in the academic faculty to really work with those projects.
And where the UIC has been able to help on that is, we may not be the right people to do the research, but we can certainly help find and locate those people, which we've been working with Jared on. So like anything, this is the good, the bad, and the ugly. The good, we did have open time on the Fib SEM. Demand existed, pair those together, that's great. Jared had plenty of expertise and knowledge in this area, which allowed us to certainly move quickly. And then also, one of the important things is this working with other academic institutions. Jared has worked with Harvard, MIT, many, basically doing the same thing he's trying to do here, working with us, and having that experience and saying, well, this is how they do it at Harvard, and sharing some of those things. And in some cases, okay, that's fine, we don't want to do that. In a lot of cases, we're able to build on that. That was very valuable. Some of the bad and ugly, do you want to talk about these?
Yeah, sure. So one of the things that was a little bit challenging at first is that as a client, when we came in and first started trying to use this equipment, there was a significant amount of sort of a lag in the learning curve. We'll go into this a little bit later, but some of this equipment is orders of magnitude more complex than the equipment that it was replacing or that was there before. And so there was a little bit of a time to ramp up before the staff was really familiar and comfortable with the instrument. And so there was a little bit more elbow grease required at the beginning than we might wanted. The other thing is that for the UIC, this kind of service was kind of unknown waters in terms of the pricing model. So how to charge, what the units should be, how that arrangement should work out, and then that also works down in terms of facility access and scheduling. It's not really a common thing for people at the UIC to let anybody from the outside world touch any of their equipment. It's usually a sort of transactional thing where one of their scientists handles it. That wasn't the best model for us, but that was new territory in terms of the university is concerned. So that was a challenge as well. And then of course there's all the paperwork, which was super exciting. Facility use agreements, non-disclosure agreements, et cetera, et cetera. And the other thing is that because of the fact that we're a for-profit business serving industry, we have really tight timelines on projects. And sometimes that just does not gel very well with people who are used to working on academic research timelines.
Does that surprise anybody?
So we can get a call and somebody says, well, our factory is dead stopped and we have 3 shifts of people standing around pacing, and we're losing $1.8 million a day. So you better figure out what the problem is. And we say, great, but then trying to work that through the university can sometimes be a little bit tricky. And then of course, one thing that's fairly obvious is we're actually competing with each other. They want to bring in clients. I want to bring in the same clients. How do we deal with that? Who gets what clients? How does that arrangement work out? When we were setting this presentation up, we actually reminisced. There was one time when someone called me up and said, "Oh, hey, I'd like to get some fib work done." And I said, "Sure, no problem." And I talked to him and I said, "Well, it'll cost about this much." And he said, "Well, how fast can you get it done?" I said, "Well, I'm going to have to talk to the university to figure out the scheduling." And they, "Oh, you're doing it up there?" I said, "Yep." They said, "All right, well, send me the price." I sent him the price. About 4 hours later, Shawn calls me up. "Hey, there's this guy who wants to do some fib work."
Which quite honestly, we weren't in a position to do. We would have needed support to be able to do that at that point. So I'm reaching out to Jared and looking for, and
It was just sort of funny because it was the same guy. He said, "Oh, you're doing it at the university? Oh, very good to know, okay." And so he got on the internet and found Shawn's phone number and called him up. Which, it turns out wasn't a big deal, but that could be a big roadblock for people. And then ultimately, the more successful our partnership is, or the more successful any testing partnership like this is, the more likely it's going to have to evolve. So at some point, and this is kind of by design, I'm going to have more capacity for FibSem than the university is going to be able to support for an outside user. And so I'll be transitioning to having my own instrument, and then we'll have to develop to a new stage. So.
And I joked with, maybe not joke, but Victor Souza and I talked a little bit about the fact that one of our successes is to be able to have a company in New Hampshire go out and buy their own instruments so they don't have to come to us anymore.
It's a success, but not from a revenue perspective, perhaps.
But how do you, and quite honestly, that's kind of what we're talking about here. And if you look at it purely from a revenue standpoint, and maybe that's not the best way to look at it, but in the big picture, that might be the best thing to happen.
Yeah.
And it actually did happen with one of your clients, I think, to some extent. Jared was doing a bunch of work for us, or with us, at our facility for somebody else, and they ended up purchasing.
I said, "Wow, that's great. We really like to be able to do that all the time. We'll go invest and buy our own stuff."
So not only did it happen to me, it happened to him too.
Yep,
so.
It happens to everybody. So yeah, I guess so. As we said, Shawn's saying, well, from a revenue perspective, that might not be the best. From a partnership perspective, that might not be the best. So in sort of working through these kinds of difficulties, we found that the key has really been to try and sort of mesh our interests by maintaining the fact that they're separate. We really want to try and match the core competency for each entity in the partnership. The UIC does some things very well. Our company does some things very well. And rather than try and blur them together and get into a position where we're trying to stretch too far, we're trying to make the square peg fit in the round hole, we need to kind of keep a little bit of distance and remember that we both have things that we're bringing to the table, which sometimes means you have to set aside a short-term interest. So it means that when a client calls both of us, rather than both of us saying, "Oh, we both want that client because that's revenue," we both have to say, well, what makes more sense for the client? What's going to make that client more happy in this particular case? And sort of trade that sort of back and forth. And keeping that in mind has been the key for us to kind of be able to work through projects and really kind of develop a much stronger partnership over time. It's challenging though. It requires a certain amount of faith and flexibility, I guess.
A few awkward moments here and there.
Oh, sure. So what we're going to try and do basically is step you through some projects that we've worked on, which also has the nice advantage of giving you some cool pictures and neat sort of technology examples. So we're going to give you like kind of the breakdown of what the framework for the project was, what we were both hoping to get out of it, and what we both brought to the table, and then how that sort of played into our long-term development. Let's go back real quick, Shawn, sorry. The one thing I will say is we're going to get into a lot of technical talk. So if anybody has anything that they go, "Oh, I don't know what that means," just throw a hand up and make some noise, and we'll stop and try and explain it so that it makes a little more sense.
And that's when you ask Jared the tough questions.
Sure.
So the first one we're going to talk about is a workshop. So what's a workshop? A workshop for us is a chance to showcase, highlight what our capabilities are, get people thinking, "Ooh, I could use that here. I might be able to use that here." Give them enough to be interested to come back. So one of the first
what we're doing now.
Okay, yeah, kind of what we're doing now, I guess. So one of the first things we with TestScan and UNH, we wanted to do a 3D workshop. So some of the capabilities of this FIB SEM are well beyond what our other SEM, and one of them is in the 3D area. So what we wanted to do was create a workshop around that, invite in folks from industry, invite folks from faculty. Basically, it was open to anybody. It was free. It was a 2-day event. The first day was basically, here's some exposure to this topic, demonstrations and so forth, and Jared will walk through that. Second day was bring your samples, we'll analyze them. We'll give you some hands-on demonstrations. So some of the types of things we looked at or demonstrated was the ability to create 3D models, physical models from images. So you do it with your cell phone and then be able to print them out. Well, we were able to do it with the SEM, and we want to demonstrate that capability. Surface analysis, so surface roughness and some really key advancements in that area. And then kind of a big area, which we hit here and then we hit a little bit later, is material volume analysis using the focused ion beam. And Jared will kind of walk us through that.
Sure. So, the UIC really wanted to, sort of put this event on and bring people in from all other areas of the faculty as well as businesses. But at the time that they were thinking about doing this, they were still kind of getting up to speed on a lot of the technology. And so there was it was that ramp up time that I was talking about earlier. However, the value of having that data actually for the workshop generated at UNH was huge. It was a nice concrete example. And so effectively what we were able to do as a partner with the UIC is we were able to come in, generate samples that would be appropriate for this type of analysis, perform the analysis, create data sets that were then able to be used as part of the workshop demonstration, and then kind of be a support during the actual workshop event. And so it made it a lot more tactile for the people who attended. And it was a pretty good success. So these are some fun examples. So this is some examples of some flywheel type surfaces where there's a metal surface and there's some machining marks, and there are some performance characteristics associated with the roughness on the surface. And using this kind of technique, you can take what would ordinarily be a picture where you'd be sort of doing some eyeball estimates into a quantitative model of the height profile of that surface, and you can do surface roughness measurements and a whole number of different analysis techniques on that. Here's another set of examples in one case where there's been some surface damage through some cratering and impacts and a fracture face. So this sort of thing is gives you a complete three-dimensional model which you can then do all sorts of analysis on. Very helpful. And then in some cases what we were able to do is then take some pictures and then convert these types of very rich, very detailed objects on an incredibly small length scale. So this is a spider palp, which is a little bit bigger than a hair. And we're able to get this kind of extraordinarily detail in 3 dimensions. In this case, this is a corrosion surface where there's some steel that's being eaten away. And so all of these things are, it's a nice sort of immediate visual response from people.
Yeah, and one of the advantages we think to being able to do this is to take something you can barely see or can't even see, be able to create an image of that, a series of images, and then blow that up and create a 3D model of it that you can actually hold in your hand. We think that would be a great educational tool.
So one of the things that comes up a lot is that when you're doing focused ion beam, there's a lot more parameters and a lot more complications you have to worry about. Focused ion beam actually allows you to do alteration to material that you're looking at in the microscope. And in this case, you can do things like microsection, or you can do implantation. You can peel off layers in the microscope. Or you can do actual microcircuit edits where you can actually change electronic devices. All of that is much more complicated, and all of that gives you a lot more things you have to worry about. So a lot of that also, there's a lot of things where there are places where you have to have some experience using these sorts of things. And as the staff at the UIC started to ramp up, they started running into issues where they weren't quite sure exactly what was causing some phenomena they were seeing. So, we had a fair bit of focused ion beam experience, and we were able to kind of help in and be an ad hoc informational resource and help people out and sort of try and explain things that were going awry, and going to get them back on the path. And it really significantly sped up the time that they were able to bring usable product to the academic community.
Yeah, had we not been able to do that, get up to speed, we would, obviously you can get there and you can get there over time, but certainly be able to do that with a lot less effort, a lot less time makes a huge difference. And being able to apply this in research immediately, not only in research but in industry, and we have, was a huge benefit to the UIC.
So this is where Shawn might have to go behind the podium, because he's going to have to click. So this is a sort of side-by-side example we viciously stole from TestScan. So this is the surface of an integrated circuit. It's probably some sort of network switching logic. And so if someone was interested in the properties of what was going on underneath the surface of that circuit, this would be the kind of thing you can do in one of these instruments. So again, this whole thing is, on the order of a hair width wide, and these are, tiny little transistors that have been set up. So in this case, what can happen is you can pick out an area of interest which has features subsurface that you're interested in doing, and do this kind of microsection work, where basically what you can do is you can create a cut down into the material you're looking for and get very high resolution information about the structure underneath the surface. So these are some examples of things that I've done up at the UIC. So these are kind of failure analysis process manufacturing problems. A couple of instances where there are some tiny little bits of debris or some materials that aren't behaving like they're supposed to, doing some semiconductor work. And in order to figure out exactly what's going on, we're able to create these kind of little microsections through these tiny little things. So this little guy right here is a whopping 220 nanometers high. And so we were actually able to slice right through that and get a side profile that showed the structure of how that material was then created and what caused it, and really helped the client out. And here are some other things. These are some crystalline materials. So these are synthetic crystals that have been created. And so using these types of techniques, we're able to see that there's a change in composition and a change in material porosity caused by a contaminant that was scavenging oxygen out of the oxide crystal. Looking at some fracture mechanics, that sort of thing. And this is an instance where there was some polymer failure, and there was a nodule inside the polymer, and people wanted to know, well, what's causing it? And so we were able to actually section down through the edge of the boundary between the nodule and the non-impacted area and get some information about the subsurface materials.
I have a question on that.
Shoot.
Can you identify compounds? When you find a contamination in there, can you tell what's contaminated?
Yes, with certain caveats. Depends on how you go about doing the analysis. But yeah, you can usually tell what it is. It depends on the size scale and how much detail you need. The bigger it is, of course, the easier it is to get more information from it. But even things down on the 10 nanometer scale, you can get some pretty good information on. Yeah. Okay. So another thing again that comes up, nanomaterials, transmission electron microscopy is kind of the go-to for really high resolution microscopy applications. It gives you sub-nanometer resolution, so you can see basically atomic lattice. You can see the spacing of individual oxygen silicon. It's pretty cool. But in order to do that, you need to be able to fire your electrons through the sample. A lot of things that you're interested in looking at aren't thin enough that you can fire electrons through them. And so in order to be able to do that type of work, you need to be able to prepare that sample down into a nice tiny thin slice. And so again, this is an application for the FibSem. So basically what you can do with that is that using that same principle of doing microsections, you can basically section in from both sides and slowly wear down a tiny little slice out of the sample that contains the information you want to acquire, and then pull that sample out. But if you can imagine, you're creating a 40 nanometer thick slice and trying to very carefully lift it away from your sample so you can put it in a different microscope. It is kind of a disaster waiting to happen. There are over 30 steps in your typical analysis. Any one of them can basically, if you do it just a slight bit wrong, will totally ruin your sample. And if you're doing a one-of-a-kind failure analysis job, and I have lost a sample because I sneezed. And it's very frustrating. So after 4 hours of work, you can do one little thing wrong and that 4 hours of work is gone. So it's a very tricky, time-consuming process. However, it's something that's very, very powerful in material science. And so it was something that we had a client that really wanted to do a lot of, but there really wasn't a lot of reference material or information about how to do it on this particular instrument. So basically,
and the UIC didn't necessarily have people beating down our door to develop it. We had people that, maybe expressed a little interest in it, but really didn't have the need at that moment to do it. But we recognized it as a really good tool that they could certainly take advantage of.
Right. So we basically volunteered to be the guinea pig. And we went in and figured out, oh yeah, well in this particular system, if you do this, it's gonna break. Or if you try and do this, it's not gonna work as well. So we worked through those sorts of process problems and kind of drilled it down and got it as perfected as you can get something that delicate. And then we were able to turn around and generate very high quality results for our client. But then on top of that, we had that knowledge now. We were then able to turn around and basically train people at the UIC in a much more efficient manner. And so that allowed the people who staff the UIC now to be able to do that for academic needs on campus on demand. And so they're doing that still today. I don't know if this is going to work, but we'll see. There's another little movie blatantly stolen from Tescan.
TEM?
It's a transmission electron microscope. So basically it fires the electrons through, and then you actually might want to see if you can drag the progress bar back to the beginning. I think that might be the problem.
Shawn, are you sure you're connected to the web?
No. No, it should be all downloaded. Okay. Anyway, we'll try and I'll show people who are interested later. But this basically is a movie of like the absolute best case scenario of how this process works, and you can see kind of all the little steps of how the sample gets prepared and whatnot. I have it on my laptop. I can show everybody later if they're interested. But this is a sample of how it goes, and even at a super time lapse, everything goes perfectly. This is like a 5-minute thing, so we just thought we'd show you that. going to skip ahead. So this is an example of how this whole process works. You know how I showed you guys before, there's this tiny little layer here that's about 200 nanometers tall. Well, that was for a semiconductor application, and they were getting some contaminants, and they wanted to know what the problem was. Using a traditional SEM, you don't get the resolution you need. And so we basically took that sample and prepared it for TEM. And so if you guys can see this scale bar right here, that whole thing is 10 nanometers. So we found these little contaminant particles. Some of them are between 2 and 4 nanometers, in size, that are embedded in the bond between these two materials. And so we were able to really blow it up. If we were able to blow this up more, you could actually see the linear lattice of the atoms in that crystal. And again, this is the same kind of thing. So this is a chip. And these solder bumps on the chip are about human hair size. And so this is the top surface. And this here indicates areas that we're going to do that prep on, where we're going to kind of drill down and try and create these slices. Doing that, we're able to find this kind of structure where, again, this bar is 100 nanometers, so this is a little bit bigger. But then we were able to zoom right in and see the individual crystals in this epitaxial layer that's grown on top of the device. So it's incredible resolution you can pull up. It's a very powerful tool. Yeah, and then I guess finally EBSD, electron backscatter diffraction. It's a really neat tool for looking at crystalline materials. It lets you look at grain size. It looks like at grain orientation. So any kind of metal or ceramic, you can get a lot of really exciting information out of it. When you're able to look at it in 3 dimensions by looking at serial sections. So you basically look at a flat surface of where the crystals are, and then you use a fib to cut down another layer, and then you look at that, and then you basically go through and stack that up until you have a whole cube of information. Physicists and metallurgists and mechanical engineers love that, because then they can take that 3-dimensional information and do all sorts of exciting modeling and understand the properties of that material in theory. And that's something that's it's sought after a lot. So in this case, UIC has been able to do this in 2 dimensions pretty frequently with a lot of people in the mechanical engineering department. The 3D is a lot more complex and a lot more challenging. And I have had people from the Department of Defense and various consulting groups that work with the armed forces who are very interested in doing that. And so we're kind of stepping in to do the guinea pig role, where we're kind of hammer out the problems and try and sort out the system. And but in order to do that, what we're doing is we're taking some samples from one of the research groups on campus, and we're doing the work for them sort of gratis, so that they'll get some 3-dimensional data while we do the sort of demonstration samples to work through the system. So again, this is sort of a couple of just stock images of sort of the information you can get. You can differentiate different forms of steel. You can look at the crystal orientation in those different forms. Austenite and ferrite, sometimes kind of difficult to differentiate. Let's skip ahead. This is kind of a little process diagram of how you do the 3-dimensional work. So you basically, you take a bunch of slices that are all at successive stages through. You take those together and you can composite them, and now you have a 3-dimensional volume. And with that, you can now do some processing. You can look for individual things. If you have one particular phase that you're super interested in, you can now just get rid of everything else in the computer, do some modeling, look at the size and orientation of that sort of thing. Again, very, very helpful for people doing theoretical calculations. And even in ceramics or semiconductors, crystal orientation is very important, and you can look at actually effective potential fracture planes and that sort of thing. So,
This is me, I think. Right?
Yeah, I guess. Yeah.
So that's, so those are some of the different projects that we've worked on together. Obviously, you can see a lot of the benefit from both of us. Even the last one, the 3D EBSD, we haven't had anybody at the university that's saying we need to do that. We know that it's going to be valuable, and once we propose this to the ME department, they're like, yes, this is great. We'd like to participate. So we're trying to lead them with the tools that they can use. In addition to that, our goal is once you're in the door, we want you to connect with other folks on campus. Where's Ellen? She should be smiling from ear to ear on that. Whether you come here to go to a football game, we want you to go to the science department, whatever. We want to engage the university. So one of the things an obvious step for us is we get a taste of something that might be research related. How do we help connect that? And so far we've had 3 different projects that have popped up.
Yeah, exactly.
Have popped up, and Jared can talk a little bit about that.
Yeah, so we've had some. Again, this is the sort of thing where I'll get somebody who's maybe a little bit interested in this, and I kind of think about it and go, well, yeah, nobody does that, but I bet I know some people if I brought this piece and that piece, and then so I'll go to Shawn and say, well, hey, I was thinking about this. Can maybe we talk to somebody in this department or that department? So one of the things we've been looking at is looking at sort of nanotribology, like looking at the structural and mechanical properties of individual micro ceramic particles. So measuring how a tiny, like 10 micron ceramic handles stress and what deformation it goes under. We've talked to people over in the mech lab over Kingsbury about doing some flexural testing on some really complex network boards, and doing some force failure and strain analysis and looking at how that stuff holds up. And then we've also done some work in looking at precipitates in polymer coatings for paints and inks and that sort of thing. And these are all things that don't quite fit in with what we do, and they don't necessarily fit in with what Shawn does, but Shawn's an excellent gatekeeper and has really been able to help set these sorts of things up, so we're pursuing these kinds of projects.
So going forward, basically we're going to continue to do what we're doing. We're going to do another workshop on the 3D EBSD at some point once we get that set up. We're going to continue to do demonstrations and so forth and involve people. We're going to use resources we can get our hands on to help develop our folks, develop our capabilities, and then showcase them to folks like you, folks across the university. We're going to keep doing that. We're going to keep trying to develop new methods, working with Jared and others, with the idea of developing these new technologies or capabilities. One of the things listed up here is, Jared is he calls me looking for somebody in mechanical engineering or whatever. I can help him with that. I often consult with Jared about, I guess somebody looking for this type of instrument, do you know where there might be one? Because my connections, although they're okay, his are much stronger. So he can help me. Yes, Harvard's got this, MIT's got this, and those types of things, or this lab has that. In addition to that, we're also looking for new instruments. We've got some pre-proposals going right now for some instruments, and one of the things we want to do is we want to make those instruments available to outside resources. So Jared's got a lot of input on, this would be useful in this area. So we involve him in some of those discussions, and these are just some of the examples that we've been speaking about lately. Other things, improve some of our internal processes. Yep, we're an academic lab, and we need to continue to refine our processes. We need to get better at providing access. We need to get better at the types of agreements that we have in place and responding. I will say I think we do a pretty decent job, but you can always get better.
Yeah, that's great. And again, the more we kind of work through this, the more we kind of sand off the rough spots. We run into a little bit of a roadblock. It's a problem at first. We figure our way around it, and then the next time we don't have to worry about that. So there's a couple of, so as Shawn was saying, we do a lot of different work. You guys are looking at picking up some new instrumentation at UNH. I threw in some examples of some of this stuff just so that you guys are a little bit exposed to it. This is one of the things Todd Gross is kind of spearheading a proposal for micro or nano CT, which is a three-dimensional X-ray technique, which allows you to non-destructively look at things in 3 dimensions. And so this is a sort of complex video processing device, and there's there's actually a carrier board for like an Intel 2011 chip and a couple of other things all kind of glopped together in this horrible military Frankenstein device. And there's a lot of different features, and so this micro CT allows you to get a view inside the device, and then in this case you can kind of create an arbitrary section, and you can just cut a line and say, well, what does it look like along that line? There's a couple of examples of that in here. This is a case where something overheated because there was a short in a power supply, and so all of this stuff is basically molten metal from the power that just heated everything the magic smoke got out. And so you can sort of see that, there's sort of melted metal here. These metal carriers that were supposed to bring voltage up and down, well, this one got blown out in the middle. And, it's sort of interesting to look at that from a failure analysis perspective. This is there's another couple of views of that, some connections, and you can come at it from different sides. This is something from an academic perspective that's very interesting when you get this kind of data, which could be appropriate for 3D EBSD, but also for micro CT. You can also do transport model analysis and modeling on it. So in this case, this is doing some analysis on what the mean free path for voltage would be if you had some conductive and non-conductive materials mixed. What would the gradient of the voltage across that material look like? So from a research perspective, it's kind of exciting.
So some final thoughts. So I think you've heard it enough, but basically partnering with Jared, partnering with the EMSL, partnering with anybody, you're going to learn some things. You're going to get some things. And I think what's really important is the flexibility, the trust. That comes with time, that comes with relationship building. It comes over a period of working together on different things. And we've been able to accelerate our timeline to get to market with some of the capabilities that we have. He's certainly a resource for engaging with industry. And it's also allowed us to not do that at the expense of the academic mission, which is important. That's why we're here, research and academics. And certainly been able to do that more effectively with Jared's help.
Yeah, and from our perspective, we've been able to really work with Shawn in order to kind of dip our toe into, or in some cases jump straight into these much more complex sort of research projects, which typically for a contract lab like us, we have deadlines, we have tight budgets, and we have people who really need to get stuff done. And so this has been a way that we can explore some of these more complex things, which really differentiate us and give us a unique service offering for clients as they come in. So yeah, I guess the takeaways are that in our experience, we've only been at this 2.5 years, but basically the framework that we thought things were going to work out, the sort of initial motivation that seemed like an obvious match, we weren't wrong about that, but it wasn't necessarily the thing that gave both of us the most benefit. We went into it with a certain sort of set of predispositions and sort of thoughts about how things were going to play out, and really only because of the fact that we kept an open mind and were honest with what each needed from the partnership, that we were able to kind of start to see these side benefits that we didn't really anticipate. And it's allowed us to kind of find new ways to work together, and I think it's made both of us a lot more strong than if we had just kind of kept and said, well, this is what we were going to do. I was going to come in and pay you and use your microscope, and you were going to take my money. Which we did, and then we still do that, right? But we've also been able to sort of expand past that and really kind of I think grow a lot more quickly and a lot more strongly than we would have if we'd been a little more stubborn about it. And so yeah, taking the long view and understanding that the value of the partnership might be more valuable than the sum of its parts, I think is kind of the takeaway we take from this.
And realizing that you probably don't know all the value you're going to get if you keep an open mind. You don't know where it's going to go. From our perspective, I'd love to have Jared do a huge research project with the mechanical engineering or the physics department or somebody like that. And so I can stick my hand up and say we helped with that. Obviously, any of those are huge successes. And I think I wasn't thinking about that. I was thinking about, I got to get this thing filled up. I got to get some revenue coming in. And those things happen, but all these other things can happen too. And is that it?
That's it.
That's it.
Yeah. Thanks.
Any questions? Mark?
So the partnership has come a long way since the early days.
Mm-hmm.
And the two, you've passed over the fact that when you're talking about agreements, you mentioned facilities use agreements and NDAs, but there's a whole lot more to the relationship that you have. And is that something that's in some overriding kind of partnership or collaboration agreement that you've had to evolve over time and started in one place and ended up in another, or what?
Right now, the agreement we have in place is a facility use agreement, which includes some things, right? It has an IP piece in there and so
But
forth.
it doesn't get into the
It
working
doesn't.
relationship.
No,
Nope,
it doesn't.
not in the slightest.
It doesn't.
Yeah. Yeah, so effectively, I mean, at the end of the day, we're both trying to serve clients, different clients or sometimes the same clients, and we're both looking out for them, and therefore we have sort of a mutual, shared interest in that, and we've basically kind of approached it from the perspective of, well, when the guy called Shawn and said, I just talked to him, I couldn't stamp my feet and go, I want to work with that guy. But I was like, all right, well, if he wants to go to you, that's fine. Because, at the end of the day, at that point especially, he probably would have called me in to come and help him with it. So saying, well, that's great. We can use this as a teaching tool and learning from it. Both of us having that kind of long view allowed us to get past that roadblock where sometimes that could be challenging. So yeah, there isn't anything really like locked down. We've just tried to feel our way through it. And I think that's not necessarily universally applicable, but I think that some of the lessons we've come through might guide other companies that would engage. From my perspective, it's not so hard for me because we work with, I don't know, 100 different companies a month on, 40 or 50 different projects from anywhere from 1 day to, 8-10 weeks. So I'm used to working with different people who have different needs. It's a little bit different, I think, for the UIC, but I think definitely they're coming along, and Shawn's got a lot of good experience towards that end. Shoot.
And I think if we did lock in on a agreement up front, it would stop all these other things. Could stop all the other things from happening.
It does seem like you hit upon a key thing is that the adaptiveness of the collaboration is what allows it to blossom and grow to
Right.
whatever it's going to. You don't even know, right?
Yeah.
You're here now. You were there then.
Yeah, exactly.
You don't know where you're going.
Right.
One thing we talked about, and every once in a while the competitive thing will come out, and we get
Yeah.
a little uncomfortable, and we joke around and we say, well, we work through that stuff. But during our discussion, we were talking about what was the when we I can't remember.
I don't know. There's so many embarrassing things I don't even remember.
Lost my train of thought. Anyway, it'll come back to me.
Okay.
Sorry.
Yeah, no, so I mean, I think the thing is, as I said, we both went into it with, these are what our objectives are. And to a large extent, we've been able to get those accomplished, but not necessarily in the shortest path. There's been a lot of kind of loop-de-loops and that sort of thing. And but I think it's okay, because I think we both harnessed a great deal of value out of that. And I think we're both at a point now where, we can handle a lot more individually and as a group. And I think that, has allowed us to grow really quickly. And take on a lot of interest.
I recall my thought. So where you were going with that is one of the things that we talked about today or yesterday, we were preparing for this, was the fact that Jared was new in his company and I was new in my company, organization. And both of us honestly weren't really 100% sure how much rope we had and that kind of thing.
Right.
And being able to understand a little more about that as time went on, and geez, we can do some things that are a little more creative, a little more different that maybe I couldn't do at my last company.
Right.
Was certainly a growing experience for both of us.
Right. I will also say though that part of the reason that works out is because my company is very flexible. Our job is to basically be the flexible analysis group that other companies don't have. So if a ISO 9001 certified group came in and said, hey, we need to do some FA on this thing and we need it done in 5 days, it would not be a good match. We're kind of flexible enough that I think we were able to adapt to that. I think a large like Fortune 500 company might not be because they have their own systems in place that are a lot more rigid and kind of restrict them. And I think we're adapted between the two of us. We're able to deal with those people. But I think expecting Lockheed Martin to swoop in and have the exact same path to success is maybe not a realistic goal.
Yes, Rush.
I have an academic question, just hypothetical. When university and industry collaborate in a situation like this, if there was a new faculty member who came to UNH who wanted to write a proposal to use this instrument, the extra capacity that was available 2 years ago,
Yeah.
how would that work with set up relationships that might, who would be...
From my perspective, the academic use would trump.
And it does now.
Yeah.
You know, it does now. The good news is we're able to work, at least right now, very easily with that. But our goal is, you know, that's our number one priority.
Right.
And so, I mean, the good news is, at least with Jared likes to spend half his nights here. So,
right.
You know, being able to authorize him to actually come in at night, 10, 11, 12, 1, 2, 3, or whatever,
right.
It actually does work for Jared in this case. So we're able to take advantage of a time that, quite honestly, is unused.
So there are no like longer term agreements that would
No.
interfere with that kind of a...
No, because when we first started out, we both knew that we were both developing and that the use on the instrument would change. And so it was counterproductive to try and lock down a certain guarantee or anything like that. So
we talked about it. It was one of the discussions was, you know, what if I, you know, whatever, and quite honestly, probably weren't in a position to do that, but it was a discussion point, and it's not something that we pursued.
And have you used this in EMSL? Is this a model that's used in other areas?
No. So we were my lab was started up to basically kind of try and shake things up and do things differently, and a lot of that was based on, you know, trying to be a lot more engaged and a lot more active with academics and high technology and R&D facilities. So yeah, to a certain extent, as Shawn was saying, I was a little guarded at first when we first started out, and then I realized, oh no, when they said just go do what you need to do, that they meant it, and so that has given us the flexibility to be able to do that.
Last question from Lindsay. Yeah, just a question. It's actually for both of you. I think one was related to you saying how much percentage of is used for sort of academics, or whether that's the priority. Is that, maybe it's not for you, but generally in the university, some assets that the university has, is that generally the case? Is like we'd like to use them as much as we can? So, you know, are the different other departments of, you know, research groups encouraged to do that kind of thing? And then I can see some issues with pricing and sort of competitiveness, and it's like, oh, we didn't have to amortize that over our, you know, whatever, like a private company would, you know, have to do. So generally, is that something that...
So from my perspective, and I'll speak on the fact that the side of instrumentation type resources, is my goal is to get, I mean, I came from manufacturing, where you get as much as you can out of what you got. And I think that should be, that's our mantra. As far as pricing goes and using, you know, government funded instrument that we're, you know, our pricing is simple. We have an internal price, which is basically the cost of operating that instrument. And then we have an external price, and honestly, the way we price ourselves is we go outside and we look and see what other people are providing for pricing, and that's what we set it. And if that pricing is below where we're charging internal, we don't do it.
I think that's where maybe some of the outside people would have some trouble with that. You just look out and say, well, I don't have those costs, I can just set a price I want. But I understand.
Well, but the thing is that you have to basically match the outside, the prevailing cost outside, because like you said, you don't want a university to start up and say, oh, the government gave me $2 million.
Right.
Oh, there's a lab trying to make hay 10 miles from me. I'm going to charge $10 for what they'd have to charge $200 for.
So I have a second half of the question for you then. It's like you obviously got a great competitive advantage. Yeah,
to some extent.
Advantage. How do you feel about another company of your competitors then working with UIC now?
Oh, that's fine. Yeah.
Okay as well?
Yeah.
Really?
I deep down in my heart of hearts, I wouldn't be like, awesome, somebody's taking the equipment time that I could be doing. But I mean, that's the way it is, you know.
Yeah, I can see why.
As Shawn was saying, like I do work at a lot of other universities, and one of the examples, the Harvard Center for Nanoscale Studies, they have all sorts of companies in there all the time. I mean, they spent $90 million just on their building, and they have a giant suite of instrumentation. And there's companies coming in and out of there all the time. Even with that, though, the companies are probably only 20%, 15% of the use down there. It's just the way it is, you know, and it's fine. It's a resource, a public resource. I'm fine with that. I like to think that I take care of the instrument better, and I try and work with people. So.
And I mean, it took a lot for us to be confident that Jared could use our instrument. Honestly, and a lot of it
was a rigorous test.
A lot of it came from, honestly, the test scan folks who knew him very well, and us overseeing it and working through that process. It's not a matter of, hey, can I come in and use your? Yeah, sure, come on in. And one of the things is we didn't have that capability before. It was send us your sample, we'll test it, and they go. Well, some people want to be able to be there and do it themselves, and we've applied that not only for Jared to come in, but to other companies, not on this particular instrument, but we apply it to the other instruments. And it's great because a company feels confident that their person actually ran the test, did the test, and the results are what they expected.
Okay, so with that, we're standing between you and networking and beverages and food, but there's plenty of opportunity for more questions. And thank you all very much for attending, and thank you both for such a great presentation.
Well, thanks for having us.